So Digi3Turbo is a software solution that helps in the framework to accelerate the framework of digitizing turbo machinery blade design process. And that includes anything from pumps and compressors all the way to jet engines. My name is Bharadwaj Dogga, and I am a PhD student here at UC in aerospace engineering. And this prototype first began as a master's thesis, wherein we were to help in the simulation learning process. We were trying to digitize these old E-cube sections from NASA, basically get numerical data to inform the current CAD models so that these papers can be converted into sections, and these sections can be then pushed into 3D models. And then once you have those 3D models, the idea was to impose boundary conditions on them and generate mass flow or figure out what the performance of old engines from the 80s and 70s look like. So when the idea and the motivation of going through Revenge Lab was that, hey, we have this really cool prototype from our master's thesis. Let's go out there and figure out if this has a market outside. So conventionally, the plan was to just target the design companies like Siemens, Dassault Systems, Ansys, et cetera, wherein it was quite straightforward because they were the targets for which we designed our education prototype for. The other space was with aerospace engine manufacturers who would, like GE Aerospace, who already had work with jet engines. So we started there, and then we moved on to look at a competition and the market data. So what we did was, there were two main barriers to this problem. The first was that both the big partners like GE and Pratt & Whitney already had their own in-house solutions. And the second part, the ones that offered the commercial solutions in the form of Software, Neometrics, and CAD/CAM services, they had long-lasting industry partnerships. So as a newcomer, going into that space and disrupting was a huge problem. And that was discovered by talking through our EIRs and by looking at market research from UC libraries. So while in conversation with one of the EIRs, they suggested, hey, Ben, instead of looking into just the design space, wherein you are targeting at one part of the product cycle, what if you look all over and look at the life cycle of a product, of a pump or a compressor? So go for design, don't just aim for design, but look for the maintenance and service industry instead. So that came as a pivot for us, and instead of just targeting the jet engine manufacturers or the CAD and CAM companies, we went over and increased our scope of audience to HVAC companies. And these would be the maintenance and servicing companies that provided services to hypermarkets like Walmart and Costco. So that's shown here as one such company, that's Hussmann. And the second area of bin that we were targeting would be aerospace engine servicing companies like Helmet Aerospace. And what they gave us was a bigger target market. Instead of our initial $7 billion market that we were looking to target, it increased it all the way down to $91 billion. So based on these, this new pivot, what we are trying to do now is understand and better refine our problem statement and take our original existing framework and convert that into a solution of a search engine for blades. Imagine a loaf of bread chopped up into slices, and then we take one slice of bread and assume that some part of it is damaged. So to fix that part is where this new framework solution would come in. And so what it would do is, if you feed a blade to it, it'll look at all the sections and tell you where that part is damaged, and then offer solutions for a given framework within a given company on how to fix it. It'll also store all that data in the form of parametric database. So instead of storing thousands of data points that come with general 3D scanning of information, this would come up. We would come up with parameters like total chord length and curvature points that would define it. And our final goal would be to integrate this into the existing ecosystem of maintenance and servicing companies, so as to not come up as a completely standalone service, but to more work closely with B2B solutions to help design their system. So my ask here to the EIRs today is for informational interviews with such companies, connections that could help us inform our solution, and that would lead towards developing further case studies to come up with a proof of concept. And you can come talk to me after the presentations, or you can contact me at these contact information here. And I would like to thank the 1819 Innovation Hub office and the College of Engineering and Applied Sciences for funding my journey through the Venture Lab. And thank you all for coming in.
Thank you so much, Ben.
You're welcome.
So the technology is way over my head, but the slices of bread I get. So thank you.
Thank you.
Does anybody have any questions for Ben? Yes,
Hi.
Mason.
So, is your solution as or more reliable than the current approach to aerospace maintenance? Because right now they're using like CMM technologies.
Could you define what CMM technologies are?
So they disassemble the engine, and they monitor for like cracks, and then through probabilistic statistics, they say all this thing's probably going to break, and that's how they make sure that planes don't crash all the time.
So this is. No, so it's more about looking at the blades and then digitizing it. Look at it as a digital twin, and then throwing it in the computer to understand how it looks like, and not towards the health monitoring side. Once it's broken, that's when we come in and figure out how can we fix this, or what can be done to fix it. More of it, if it's broken, then what do we do with it? Yeah. Thank you. Sorry, go ahead.
Is this targeting like legacy equipment from these manufacturers? It's not new engines, it would be all the old.
Right, so it's more for existing ones, and so the design part is really saturated at the moment. That's what we discovered by talking to libraries and the EIRs, that hey, if you're going after new engines, first of all, it's proprietary, and even the compressors and pumps, they try to keep it a nice little secret, so don't go after them there. But for servicing and maintenance, it's out in the open, and they're more readily available to share the problems with you because it's dirty. Yeah, thank you.
Okay. All right, Ben. Thank you so much.